different tools, roles, and outcomes.
Yeah.
I'm sure this will be insightful. Hello, guys. Good evening to all of you. As part of our new initiative at Utilitarian Labs, where we have started certain training sessions as part of the knowledge consultant knowledge series, today we have a session on data analytics, specifically with the roles of data analysts, scientists, data scientists, and data engineers. We are going to talk about how these functions are going to use or translate raw data into real business use cases and further insights on these roles and their impact. To take us through this, we have Angu Vasan with us today, who works closely with data platforms, analytics pipelines, and real world use cases where data actually not only drives outcomes but also provides the leadership to take the right decisions. Angu Vasan brings a practitioner's perspective to this topic and will help us connect dots between the tools, roles, and the outcomes. I'm sure this will be a very insightful and useful session for all of us. Over to you, Angu Vasan.
Thank you, Kiran sir. So hi everyone. So you basically know who I am. So I work in the Tableau team as a data analyst. So today I'm going to take a session on what is data analytics and data analysis means, and the different roles of the key pillars of the data analytics department. That is data analysts, data scientists, and data engineers. So moving on, I want this session to be as interactive as possible. I would like to ask questions and I want you guys to answer as well. Okay? So moving on, this is our today's agenda. So we're going to start with why this topic is very important. So can anyone say why this topic is very important? Why data is very important in today's market? Can anyone? Data becomes void. You're correct. So basically what happens is, previously data was part of only the IT asset. Nowadays, even a social media platform itself, even a small content creator uses this insight to grow their channels and audiences. So data plays a vast role in every single aspect of our life. For an organization point of view, it starts from the HR to the operation level. So everywhere the decision has been made today is based on data. So there's no data or instinct is used today nowadays without data. Moving forward, as you said, the new oil, data is the new currency. So can anyone say why Google is one of the most successful company in the world? Anyone? From this side I would like answers. What's a lot of data? So basically the structure is like this. Google's business domain is structured like this. So basically us as an end user, we use all these platforms from YouTube, Google search, Android phones, all these are open source. That's the one common thing. So from there Google collects the data from various sources, not just your Google search history, from the Google pages, even from the other websites, because we use the cookies. So that tracks all this information Google collects. So if you know, Google is an advertisement company. Majority of the revenue comes from the advertisement. That is about 70 to 80% of their yearly revenue comes from advertisement. So their main target is advertisement. Every ad you see on your phones, everywhere comes from Google. So that's why Google has a very structured business market in this domain. So they just target the audience, they just generate in that, revenue, as well as they'll sell the data which we have to the third parties like some banks or Amazon, some retailers, and they generate income through this. This is why Google makes such a huge investment on advertisement and on analytics part. That's why we are big data and GCP are a very big source nowadays. Moving on. So I'd like to give an example. So what do you see from this data? That's a count, but when you see the count, there are totally 80 members are working in this organization today. 50 are attending this session, 30 are not attending. If someone from the management side comes and asks us why these 30 members are not attending, what is the answer as a organizers will give for the management? That's where the data comes. This is the raw data. It does not have any meaning. We do not know why these 30 members did not attend. That's why data is a raw, unorganized facts without any context. So what is context now? Context is basically a detail, like why all those questions we ask, why, how, those are nothing but the context, which gives some meaningful information about the data. Moving on, as an example, so a management side comes and asks us why 30 members did not attend this meeting. When you start questioning, are they in a client meeting? Are they, or this topic is irrelevant to them? So this information we'll get. As a result, we'll be finding the outputs are many are attending the client meeting. Our session is irrelevant for many people. So this is the output we find from this questioning through the context. So this is the findings we'll get. Session timing is conflicting with the client meeting, and the target audience is not addressed properly. So this is the reason why we have 30 member shortage, that is about 40% of the organization missing from the session. That is nothing but we call it as insight. Insight, which is a context, a data with context and meaningful information, gives us the insight, what is happened, what we have to do. This is the basic foundation of data analytics part. Moving on, this is the data structure. It's similar to a raw mining industry. So you have data from various sources, you process the sources, and you make a useful product at the end. This is the basic flow, how the data is organized and analyzed. So we have three types of data structures. One is structured data, semi-structured, and unstructured data. So can anyone give me an example of what is unstructured data? Anyone? Please, go on. Okay, we have three structured data. The structured data is like which we have it in a table structure or an spreadsheet, which is structured and organized well. Semi-structured, the JSON script, XML files, JSON, all those things comes under semi-structured data. Unstructured, we have images, footages where we can't say anything without analyzing the process. So it could be, because it's both semi as well as unstructured. So these are the two important things which people should learn: qualitative and quantitative data. So what is qualitative data? Basically, to put it simple, every comment you make on a social media post, that is qualitative, because you are just commenting on the post. Quantitative means the likes you put on a Facebook picture or something. So that number can be calculated, but you can't calculate the comments. What is the comments is all about? You can only calculate how many comments are there. So that is the major difference. As you see the example, it's based on, qualitative is based on your social media analysis, like comment session, whereas quantitative is a structured number of comments, number of likes, number of shares. It's as simple as that. So now come to the big topic. What is data analysis? What do you know from the word data analysis? Exactly. So the data is, we have the data in a structured format everywhere. We have to fetch the data in order to go, when we sit with the client, they'll have a problem. That's why they need an analyst. So if they have a problem, means they'll have a lot of inputs, questions to be answered. So that's why we have to, as an analyst, we have to go fetch the data, what is the issue, then fetch the data. The data will be in any format. It could be in XML, it could be like, as I said, unstructured, structured, it could be any format. We have to clean the data based on the historical data, which is already stored in a system. So we take the data, as I said, this is the process. From the business questions will be there. We have to get those information and data, then we have to explore the data. So we may not need an entire data structure. We might need only few structured data. So we have to fetch those information, prepare it for the according to the requirements, analyze those data, then present it to the findings. The purpose is very simple. We have to find a pattern. Always there will be a pattern. Like for an example, us as a human being will always have a pattern. For example, we'll refill our car tanks or fuel tanks, in bike tanks, in particularly 2 petrol bunks. One is near the house, another one is near the office. These are the 2 things we do as a human being. Very rare conditions, we'll go outside those 2 bunks. So this is a pattern. Yep.
If that's the case, then what is the very difference between data analysis and data processing?
Processing, it's similar to like for a project, we prepare a data, in a sense cleaning up the data and needed some inputs from the client. Processing, in a sense, we might get it from different sources. We have to process it accordingly. So we might have some clean data missing, some missing will be there. So certain things will be has to be addressed. So typical question, analysis, answers, these are the 4 questions. These are 4 questions, even in analytics we'll be answering the same questions. So what happened, why it happened, what pattern or anomalies is existing, or how did the performance change over time. For a company like Amazon, if the sales drops, they need to know like right away why the sales has dropped. Because sometime, for an example, right, recently we had the Republic Day sale. Till Republic Day, we'll have a high sale. The next day it would have dropped. So there is a change in the pattern. So because the sales during the Republic Day, there's up. Once the sales are down, discounts are down, prices people are not buying. So these kind of information we'll get from this analysis process. Moving on. So as I gave an earlier example, so we have 80 members, 50 are attending, 30 are not attending. That's about 40% are not attending. As an organization, that is a huge percentage. So when we go and ask these questions, why, what happened, all those questions, we end up finding these issues. So a meeting is overlapping with the clients and topics are irrelevant for many people. Maybe this analytic topic may be irrelevant for the admin people. So they may not be attending. So these kind of things we'll start finding as we dig further and further. So these questions when you ask, you'll end up finding what happened, why it happened, all those information. So as an organizers, we can plan accordingly. Okay, what is analytics? The definition between analysis and analytics is pretty much the same. Well, the only difference is these are the 4 analytical level. The purpose is like what will happen next. Like if you are going at the same level, 30 people, 40 people are missing every time when you are doing a session, that is a big issue. How to solve that? It's a task we have. That is where analytics come into the picture. So as I said, there are 4 types of analytics. One is descriptive, diagnostic, predictive, and prescriptive. So descriptive is nothing but what happened. Why the 30 odd people did not attend? This is the question will be there asked. So this is based on the fact data which we already have, because based on attendance from various sources. People are attending from online. So that comes into this. We just get a plain numbers. 30 people are there, 50 people are attending, 30 people are missing. Next, diagnostic. Why did this happen? So again, it comes to that why questions. Why people do not attend? So here we'll come to conclusion that, okay, this there were client meeting in the exactly the time conflict is there, and topic is irrelevant. Again, we'll find this information. Predictive. This is the forecasting. This is one of the very important aspect as for a sales company or e-commerce company to predict what will happen in the upcoming days, how the sales will happen, all those things. Forecasting is very helpful. So attendance has dropped. So if this happens, what will be the cause? What is the point of adding? Those questions will be answered in the predictive part. Prescriptive part, what is next? So how to find a solution? So in order to find a solution, so if the meeting conflict is happening, then we have to reschedule this session timing, or we have to find the right topics to discuss so that everyone comes and do. These are the answers will be predictive analysis will do based on the data we get by asking questions. So these are the basic difference between analysis and analytics. Although both the process is same, the prediction model is differs. That is one outstanding. So if you see the outcome, we understand only with the current data, based on current data and the past data. But in analytics, we have to predict the future trends. Like if you change the topic, what will be the result? All those things we have to be done by the analytics process. As I said, I given an example on sales. If there is a Republic Day sale, it was dropped. Next month, Valentine's Day comes in. So again, we drop another sales discount for Valentine's Day, the price. So these are big companies, organization, they do a performance testing on this kind. Then they decide the product pricing and discounting accordingly. So as I said, data analytics is pretty much like forensic analysis. Like how a crime scene detective goes and says, it's exactly like that. You have to go and fish into the data. So first, when you sit with the client, we'll ask what is the challenge, what is the problem the business is facing. Second, prepare. We have to collect data from various data sources. It could be a text file, it could be a table structure, it could be unstructured data, whatever it is. It could be even sometime in some cases it could be an encrypted file. So many different data we have, like as you asked, processing, cleaning and integrity. Integrity means duplicates, redundancy, all those things has to be managed. So those things has to be processed during the processing stage. And analysis. So each data has a pattern. As I said, gave you an example, a person has a pattern. Like he wakes up at this particular time means he has this routine. So it continues for as long as there is an interruption. So that's what we have to find as an analyst. We have to find those patterns. Explore visual, then we have to convert it into a visual expression, visual dashboard, then we have to present it to the stakeholders. And next is sharing. Nobody gets it right away, correct data. So I would have understood something, the requirement would be something. So it's very important always to go sit with the analysts, sit with the stakeholders or product managers to get, is this the product you wanted? Because at the end of the day, they might require something and you might give them something. So it's always important to go and question them whether this is the data you wanted or not. Once everything is set, then comes the task. This will be given to the stakeholders or the respective people so that they can make the decisions based on this information, insights we provide to them. So can anyone say, what are the three, these are the three pillars, data analytics, data analyst, data scientist and data engineer. These are the three pillars of data today. Even though we have multiple roles, there are plenty of roles. There is credit analyst, risk analyst is there, market analyst is there. These are only few of them I mentioned here. There are plenty of roles under data. These are only few. So as I said, data is everywhere. Everything we do today is recorded somewhere. And it is used as a marketing tool for many companies to target the audience and how to improve their business. So many things they use this data. So can anyone say what does data engineer do? Exactly. So data comes from various sources. Like as I said, it comes from a mainframe files, it comes from a text file, it comes from an Excel sheet, from various different sources, even from various different cloud platforms. It all has to be combined. For an example, let's say in a banking sector, data comes from a manager in the branch manager in a text format or an Excel format, as well as transaction happens in an ATM or internet banking. All this data will be stored in a different platforms. So all has to be stored in one particular place so that when you go and open your account details in your system or phone, it has to show your balance properly. So all has to be stored in somewhere. So all this data will be stored, and data engineer are key responsible to get the data stored properly and it's accessible whenever it is needed, so that every user can access whenever they want it without any interruption. This is one of the very important pillar for data engineering, because let's say today is AI. If the LLM database is crashing, without LLM the AI tools will not work. So basically, who runs the LLM? The data engineers. So example, let's say we have a session, 80 members, 50 members are attending, 30 members. How did we know this 50 members are attending, 30 members are not attending? Because there few will be attending from the online, few might be attending through sessions right here in person. So we cannot know how many are actually attending. So we use data sources from different platforms, and we make a conclusion, okay, 30 members have attended, we have come to this point. Even though people are sitting here, could be also recording the session through their phone. That could create a duplicate data. That's why cleaning and storing works here. Making data analyst available. Data is available. The analyst should be able to access the data whenever it's needed according to the business requirement. So if I wanted to see why these 30 people are not available, I have to look into it. So based on this attendance data, I have to find how many are duplicates, how many are not attending, all those things I can get more detail as I look into the data. Okay, what is data analyst?
Examines the process.
Yes,
And works on the process.
exactly. So we have a problem, like as I said, 30 members are missing. So why they are missing is a question which business as a management you'll ask me if to the organization, why 30 members are missing. So that is a business requirement. So we have to get the data from the data sets which data engineers stored. It could be duplicate, there could be junk data, so many things will be there. We have to refine it and we have to find a trend. Why the trend is very important in a sense, if the session is happening for past 2 months, if there is a up and down in attendance, there is a trend. Every 2 weeks or something, everyone are attending in the first session, second session 70, third session only 60, fifth session is 50. So it's going at a downward trend. So we find a trend and make a decision accordingly. So that, okay, the topics is not proper, either the meeting conflicts are happening, all these things the trend analysis does this. Then we put up into a visual board, in a dashboard, so that we can't explain this to our stakeholders or the CEO of the company. So they have to open up and they see, they'll understand, they'll move on. Okay, this is happening, change this, they move on. That's why storytelling is very big part of data analyst. So that's how you create a dashboard, so that as soon as a person sees the dashboard, they understand, okay, this is what is meant. So this has to be done. So storytelling is very important. That's why if you remember in the previous step why sharing is very important, this is the reason. Because each insights, my style of analyzing the data will be different. The business wanted the data will be different. So it's very, very important that we keep a very open storytelling board, so that everyone who sees the board, who understands, okay, this is this data, so we have to make this kind of decision. So as I gave an example, data analyst, as we analyze the data, why these 30 people are not, then we find a pattern. As I give you an example, 50, 60 dropped. Then we find who attended, why who did not, which team is missing. Like for example, we have multiple teams working. So certain teams will have a client meeting, certain teams may be not relevant for this. So who are not attending? Is the attendance changing over time? Like as I said, dropping from the 50s to 70s, like that. So this information gives us a lot of insight as an organization to make a decision to change, either change the topics or changing the timing, so that people can have be able to come and attend the session without any issues. Okay, data science.
Predicting and
Yes.
outcomes and serving actions.
Yes. So data analyst sees the data in the past and the present, whereas data scientists will go further and he'll say, if we make a change in this, what could happen in the future? So up until now, it's all basic SQLs, basic Python scripting will be required. When you come into this, you will lead all the machine learning, all the algorithm, mathematics, everything gets involved here. So here here's where the money is lies actually. Everything has to be done here. It's basically full stack development. They may not need to know the entire SQL part, but they need to know the entire coding part. So in order to, if they know that, they can predict the data, read the data, analyze it, and then predict what will happen in the future. So as I said, statistics and machine learning is the core for data science. Then they have to conduct multiple experiments, like if I change the time slot based on the calendar as well as this schedule timing, they have to analyze it, what will happen if I change this thing. All this forecasting, everything will be done right here. So as a result, they will give us a proper, it will not be a proper, nobody can predict properly, but you will have a stepping stone so that we can make a decision accordingly. Because every data may not be correct. It changes according to the time zone. So this is a basic difference between data analyst, data science, and data engineer. So the working is pretty much the same. The workload is same, but the thing is each level goes in the advanced. So data engineer works on the pipelines of data, how to store, where to store, or how to extract all those information. Data analyst will come and look into the past data and present data to give you a facts what is happening in the organization currently. Data scientist will give us the future prediction, the forecasting, what could happen if you make a small changes, all those information. This is the basic difference between data analyst, data engineer, and data science. Any questions? No questions. Moving on, as I said, these are the tools which is needed. So for an analyst, you need to be at least an intermediate level. For a data engineer, he has to be in an advanced level. For data science, he has to be again in an intermediate level to access the database. So Python is very important for data science because it has to handle a lot of data and has to work with multiple scenarios. So Python makes a big difference. Whereas as an analyst, you need a Python as extensively as other two categories. Statistics, it's depends on their requirement. And then BI tool, what all BI tools is Power BI, Tableau, and Alteryx are the BI tools. Big data, it's again data sets, data warehouse. Cloud technologies, there is a small change. The cloud technology data analyst should know a little in the intermediate level so that they can access the data from various cloud system and do the modeling in their development. Business communication is very important for data analysts. So if you go and sit with a client, they always come with a problem. See, I have this problem, how to solve it, where is the issue? This is what we have to analyze. The other two may not need that much extensive business communication, but the data analysts need it because they are the ones who get the core problem issues and everything, and they have to replicate it in the dashboard version. So this is the very important aspect as per my knowledge. For me, 5 whys. This gets to the root cause of every single issues. So the 5 whys is simple technique which I have been using. So for an example, I'll give you an example. Like Amazon is there. They suddenly have a increasing customer report saying that, complaint saying that their deliveries are very bad. So in order to analyze this, Amazon gets into the data analyst and gives this problem. See, we have this problem, poor grocery delivery system. Why? The Amazon stakeholders will ask. As an analyst, first question you will be asking, what is the customer complaint is about? Why the customers are complaining? The very first question we will be asking. The second question is, as we analyze during that process, we will be finding, okay, as per the customer report, where we will have to do an extensive Python scripting to get the summary of the data. Like, okay, the products are damaged. This is what the customer would have been complaining. Then the next question, why are the products arriving damaged to the customer location? Again, you have to go and look into the third why. That will be the second why. Then now come into the third why. The packages are not packed properly. It gives you some insights. Okay, the packages are not properly packed. So we are not delivery gets damaged. During delivery, it gets damaged. That leads to the fourth why. Why it is not packed properly? So because it's, as an organization, packing is, they spend an extensive amount of money on packages. So if it is not packed properly, means the goods are also waste, the money is also waste, the time they invested is also waste. So that leads to the fourth question is why the packages are not packed. The fifth question will lead us packers are not completed a requirement. So there's a salesperson who packs the bags every time. So if they're not packing it properly, means why is they not packing the properly? That was the fourth question. So when you come to the fifth why, so they are not trained properly. So if they're not trained properly to pack a goods, so obviously the package will be damaged while you're delivering. So this is an obvious question answer. So it's not restricted only for 5 whys. You can go to the 6th whys. It's question 6 why. You can go as long as you want to find the root cause. It doesn't stop with 5 whys. So as we find the root cause is the packers are not trained properly. So this gives them inside that the training is not properly. Then you go to the 6th why, like why are they not trained properly? Then 7th question, if the 6th question gives an answer like the trainer is not available or the training video is not available. Why this next question, 7th why it is not or not available? So it keeps on going to find the root cause. At some point it will end, but this is how it goes. So any questions?
Like people in case of client, it is
Product based company, like Amazon is an example. Amazon is a product based company. They have various product, not just the e-commerce side, they have the technology side. In technology side you have lot of sales as well. So you have software, you have AWS, they have to sell the softwares. So if the sales drops up and down, so why there's a sales drop? Why there's a sudden sales increase? All these comes to a question, right? In that particular time, we have to analyze the data. So for an example, in the month of April, there will be a sales side. In the month of January or December, there will be a sales drop. Why? Because it's a holiday season. So obviously people will not be using, the sales will be going down. At the month of April, the sales goes up. Why? Because it's a new financial year, people need more services, so the sales goes up. So they also needed the analysis. Yeah. Any more questions?
Sir, in the couple of slides before you were showing the difference between data analyst, data specialist, and
This one?
would you explain data specialist?
Data specialist is encoded everything. Just give me a second. There's a lot of categories. So the basic difference is all these things are interlinked. Everywhere you do the same work. Okay, the thing is your responsibility will be different. In some cases, data scientists also will be storing data somewhere. The data analyst also will be stored. The main work of data engineer is to store the data. But in most of the cases, everyone will store and retrieve the data as well. So data specialist organized. So it is pretty much that is equal to the data science engineer only, but there's a little organization. I'm not specifically on this topic. I'll come back to you on that later. But there are so many things are there. Market analyst is there, credit analyst is there. So many roles are there.
How do we handle unstructured data?
So unstructured data, if it is a video footage, for an example, we use machine learning algorithm. So currently, if you've seen all over the Bangalore, all the traffic signals are cameras. The technology they currently have is, if you around, like if you can literally type in saying that at 1:30 a green car passed, it gives that number plate to you. So you train the algorithm to do that work. So if a car goes, it's a green color car. You have to train those things to get it structured to get us retrieved. That's where data scientist comes to picture. So nowadays it's very easy to find like which car passed at which particular time. This is implemented in Mumbai. It's currently inactive in Mumbai in traffic control. In Bangalore, it is not yet available.
You just mentioned that data scientists are mostly responsible for like predicting like what exactly that is going to be the outcome in future, right? The future prediction. So the very situation we went on to like bring upon.
Beg your pardon?
I think data engineer is responsible for the same.
Can you come up again?
No, no, data engineer is responsible for
Pipeline,
the
storing the data.
processing of data.
Yeah. So here we are not predicting it, right? Here we are processing like what exactly.
A data
has happened
analyst
in,
role you are saying. Yeah,
past.
probably what you're saying is a data analyst also can do this role.
See,
is
the
what-
role,
Data engineer.
everything is
engineer,
same. To be honest, the responsibility only varies. The almost the response you have seen the coding, scripting, almost everything is needed. As you go, the responsibility varies. The workload is pretty much the same, but the focus will be on different topics.
We are bringing upon the past data, right?
Yeah.
The car has passed at that particular time.
Yeah, but in
That's
future
what,
you are coming and asking like what time the car passed. Okay, that is a prediction, right? You have to predict at exactly what time the car is passing.
So it's like this. It is not. It's not under data analysis. It is one step ahead. We are using machine learning here to predict based on a color, which is an unstructured data. A car has passed. Camera has captured the car. Now you'll have to predict what is the number of that car at what time it passed. You know, a lot of data has to be taken from that.
You have
It's
your only
unstructured data. From an unstructured data to collect some analysis and throughout that analysis is a data scientist job is what he's trying to say. Now your point is it's not even a data engineer. Data engineer only processes the data. Data analyst then gives you analysis on that data. So the past, whatever he said, past and present analysis of data is done by a data analyst, not by a data engineer. And a data scientist does predictive and prescription. Based on predictive analysis, he gives you based on the outcomes, he'll give you the actions. What can be the actions on that? To give you in a layman's language, a doctor. A doctor performing a postmortem is a data analyst job. Past, what happened? How did he die? What time he died? Postmortem. A data scientist is doing a doctor's job where he is examining, diagnosing the problem and trying to predict what can happen, what medicine he should prescribing, what medicine he should take, so that you get active. So that's the difference between a data analyst and a data scientist. Okay, thank you very much, Angu. That was a very useful session. And the very purpose of having such sessions is that learnings are not confined to individuals. Learnings from our projects that we execute at different levels are shared with the outside world within utilitarian labs and also outside, because we are making these videos live on our utilitarian labs YouTube channel. So it's available to people outside the utilitarian labs world also. So it was a wonderful session. I think we would be having more such sessions going forward. And I am sure, though it is pertaining to data, data is everywhere. Even as Salesforce developers and Salesforce consultants and project managers, it becomes very useful to understand about data, because at the end of the day, our customers are also interested to know. They work on data. They want to know how a CRM can help them with the data, because they also have ERPs. A lot of data is stored in silos. How do you pick up the data and analyze the data and throw those dashboards and reports using Salesforce is what a consultant's job, right? So I think understanding data is very important, and I'm sure it has helped each one of us here in understanding data, and we will use it in our day-to-day future experience also. Thank you all for joining.
Thank you. So one thing I like to say is you have to be interactive.